All right, guys, here's your video for putting it all together and graphing these rational functions. You'll see that I have two rational functions here, some tables to help organize my information that I'll go ahead and fill in. This sheet is linked for you as a PDF in Canvas, so if you'd like to follow along, you are certainly welcome to. So the first thing that I want to go ahead and do is I want to factor my rational function. So I'll go ahead and factor my numerator here. So I'm looking for things that multiply to give me -8 that add up to +2. So I'll have 4 and 2, and I'm looking for +4 and -2. In my denominator, I'm first going to pull out a 2, and I'll be left with 2. Actually, you know what? Let's pull out a 4 instead. What am I thinking here? We'll pull out a 4. I'm left with x squared plus 2x minus 3. So 4, and I can go ahead and factor this. I'm looking for things that multiply to give me -3 that add up to +2. So here I have +3 and a -1. So I went ahead and factored my rational function. So what I want to do now is go ahead and set my numerator equal to 0. And that will give me two roots, one at -4 and one at +2. So I'm going to go ahead and plot those, one at -4, one at +2. My y-intercept, I can plug 0 in for x. So here I'll end up getting 0 plus 4, 0 minus 2, all over 4 times 0 plus 3, 0 minus 1. This is going to give me 4 times -2 all over 4 times 3 times -1. So -8 over -12. So my y-intercept is at +8 over 12, which I can go ahead and simplify. I can divide both of these by 4 and get 2/3. So at +2/3, I will have we'll stick that right there. I will have my y-intercept. Let's see. Now I can go ahead and find my horizontal asymptote. So looking at the degree of my numerator and the degree of my denominator, it looks like they're equal. So I need to divide the lead coefficients. So for my horizontal asymptote, y is equal to, my lead coefficients are 1/4. So here at y equals 1/4, so let's see, I'm going to zoom in so I can sort of sketch around here. Here at y is 1/4, I will have my y-intercept, my horizontal asymptote. My vertical asymptote, I can go ahead and set my denominator here equal to 0. So I know that my restrictions, I know that x can't equal -3 or +1. So I know that I have a vertical asymptote when x is equal to -3 and +1. So I'll also come in here and sketch in my -3 and my +1. So now I'm at the point where I can start to pick some values and plug them into my function in order to figure out sort of where my function exists. But what I do know is that my y-intercept is up here, so I know that I'll have a nice chunk of my function that looks like this. And because of these values over here, I know, and I'm sure that you'll do a much nicer job sketching in than I am with this Apple Pencil right now, but this will be nice and curvy. This will be nice and curvy, and it will just get closer and closer and closer to that asymptote. So there's my first function. I can come down here and keep filling in. My domain is x values such that x is not equal to -3 or 1. And my range is y value such that y is not equal to 1/4. So there we are. There's my first rational function. So I'm just going to actually go ahead and delete some of this so that I have a little space for myself to do this other problem over here. So now I'm going to take a look at this guy right here. I am going to find my roots by setting my numerator. So x minus 2 equals 0. So x is equal to 2. So here is my root. My y-intercept, I can plug 0 in for x. So here I get negative 2 over positive 16. So my y-intercept is going to be at negative 1/8. So negative 1/8. So 0 comma negative 1/8. So we'll come over here and we'll be really, really close. Let's see. My horizontal asymptote, I can look at my original function. It looks like the degree of my numerator is equal to the degree of my denominator. So I'll divide my lead coefficients. So I'll divide 1 and negative 4. So y is equal to negative 1/4. And I can come in here and really sketch in my horizontal asymptote. I know this is a little boring and maybe a little tedious, but we're just sort of putting all the pieces together. For my vertical asymptote, I can set my denominator equal to 0, so negative 4x plus 16 is equal to 0. So I will get negative 16 divided by negative 4 is equal to x, so positive 4. So when x is equal to 4, which means that x can't equal 4. So here at positive 4, I can sketch in my vertical asymptote and make that a little nicer up top. So let's take a look here. I would like to, oh, you know what? I just realized that my horizontal asymptote is at negative 1/4 and I accidentally sketched it in at positive 1/4. So let's just come in and take care of that. So here, we're just gonna sketch this in as the negative piece right there. There we go, that looks a little bit better. All right, so now let's see. I have my roots, my y-intercept, my horizontal asymptote, my vertical asymptote, my domain, x value such that x is not equal to 4, and my range, y value such that y is not equal to negative 1/4. So now I can go ahead and see that I know that my function's going to exist over here because I have these points over here. So I'll just sketch this in and follow my asymptotes sort of as my guide. And now I can pick another point. I can pick a point like 6. If I pick 6, here, let's erase some of this, give us some space here. If I pick a point like 6, 6 minus 2 all over negative 4 times 6 plus 16. This is going to give me 4 over, this is going to give me a negative value. So since I don't even really need to evaluate, I could evaluate, but I know that since it's negative, that my function will exist somewhere down over here. So this is just a nice sketch of this rational function here. So you'll have a few to do for homework. Please do them on graph paper. Please make sure that you're hitting all of these points, these sort of key pieces that we've been talking about. And make sure that you come to class on Tuesday or Thursday or reach out to me if you have any questions.